Hello, welcome back. In this segment, I want to talk about null-free shellcode. What I mean by null-free shellcode is, let's take this example. We have an exit system call. We talked about how to make system calls in the past segments. Here, for example, exit means EAX value has to be 1. EBX is the status of the exit. I say 0 to EBX because I wanted to do exit of 0. Okay. And then we make an interrupt. If you now compile this, right, and disassemble this code, and look at the machine code. I can look at this and show you the machine code, right? What you're seeing is that, for example, move 1 to EAX would have B801 and then a bunch of 00s, right? So these are null bytes. Each byte here that I'm circling is a null byte. So we don't want null bytes in the context of buffer overflow attacks. Suppose you are doing offensive security and you want to send some payload. Usually null bytes are not good. For example, if there is a string copy will not continue after the null byte. So how do you get rid of null bytes in shellcode? It's an interesting question. So I will talk about some strategies people use to get rid of null bytes. Okay, let's do that. Suppose I rewrite the same, right, as follows. Okay, I'm still doing the exit call here. Exit is just an example. Remember, the goal is to do exit of 0. Exit requires EAX to be 1 and EBX should be the status. Okay, this is the status. And exit system call requires EAX to be 1. How do we get EAX to be 1 in this case and EBX to be 0? We can do a simple trick. We do XOR of EAX with EAX. That means EAX will be 0. And then we do move B. B means byte. Only we are moving a byte value 1 to AL. AL means the least significant 8 bits of the EAX register. Okay. And then, okay, well, in this case, we solve the problem. EAX becomes 1 at this point, right? All right. And then we have EBX to be 0, which is simple. We do XOR with EBX. Okay. That's one possible way to do it. Let's look at it, the assembly code. Let's compile and link. And then we will disassemble and see there is no null here. We got rid of null. We have EAX to be 0 because of XOR of EAX. And then we increment or rather move a byte to the AL part, right? AL is the least significant 8 bits of the EAX register. Okay, this is basically it. We can also do one more thing. We do exit with no null.s, right? Let's try, instead of move B1 to AL, let's try inc. Yeah, EAX. Let's see what happens if you do that, whether any zeros, any null byte occurs or not. There are no null bytes, but the advantage in this case is that we saved one byte. The reason I say so is that EAX just requires only 1 byte. If you look at the move 1 to AL requires 2 bytes. Okay, in shellcode injection, each and every byte matters. The smaller the shellcode, the better it is. Okay, so that we can send a small amount of shellcode and execute malicious code in the offensive security context. Okay, if the buffer size is small, you want to send small shellcode. All right, so we already saw some small tricks. Okay, replacing move 0 by XOR with register and the register name. EAX will set the EAX to be 0. We also saw some neat tricks like move 1 to AL using the move B instruction. Okay, all right. And then we also saw how we can save a byte by using an inc instruction rather than a move instruction. Okay, moving 1 to AL is same as inc and EAX. So those are some of the neat tricks people use to avoid null bytes, try to reduce the number of bytes in the shellcode using inc instead of move, for example. Okay, that's basically it. Thank you very much.